Welcome to Catalyst Conversations. I'm super psyched for our second session. Your hosts, Johnny and I, wanted to put together something in the innovation space for some time. We've both been involved in supporting research-based ventures, and the idea of Catalyst Conversations is built on a community of like-minded individuals interested in learning about the problems of our world from a research perspective and being introduced to research teams and ventures working on commercial solutions to these problems. And rather than just doing another podcast, we want our sessions to be actionable for the listeners, for you, by providing an opportunity for you to get involved with the topics and the teams that come to our show. The guiding principle, as always, is that the show is easygoing, to the point, and engaging. And without further ado, Johnny, what are we talking about today and who are our guests?
Thanks, Roman. So today we're talking about endoscopy and tracheal intubation. Before I introduce the guest, I'm just going to briefly say, why are these important? Well, first of all, intubation is important because it saves lives. Lives are saved when breathing is compromised, and then you need, for example, to use the intubation method. And with endoscopy, you can detect diseases very early. We're going to hear a lot more about this later, but through this process, you can examine the esophagus, the stomach, or intestines in your body. And today, our guest that will talk about this more further is Philipp Ganz, who is the CEO and co-founder of AI Endoscopic. Philipp has a bachelor in physics in the University of Vienna, and also a master's in biomedical engineering with a focus in physics from ETH Zurich. Philipp, welcome.
Thank you for having me.
So I explained briefly the difference between tracheal intubation and endoscopy, but I think you know much more about this. So how would you say these two topics are differentiated?
Well, one of them is a general method, for example, endoscopy. This comes actually from the Greek word for looking inside. But in this field, in the medical terms, you always exclude radiology. So when you use X-rays, it doesn't count. But in general, for us, it's when you put a camera inside of the body, doesn't matter how, it's called endoscopy. And now when you hear medical people talk about it, they then say colonoscopy, bronchoscopy, and actually this scopy always is the indicator that it's a camera somewhere. And the first one is where it's done. So when you say bronchoscopy, it's the bronchi of the lungs. And then you already have an idea of what this process is about. When we today, especially for tracheal intubation, we're going to talk a lot about laryngoscopy. So you look at the larynx, so really shallow, via the oral cavity of the patient, because for tracheal intubation, this is not something to look at. You can also do it actually without a camera, because actually the view is good enough. But the point is that you actually place a tube via the mouth into the patient's windpipe to assure the lungs ventilation. But you already gave a high-level introduction why you need it and what is it for.
And from what I've read, the biggest amount of accidents, if you will, happened in the intubation space. I read a statistic that about 40% of the procedures don't go as planned. Is that right?
Yeah, you sure. It depends how you formulate it. You always need to be a little bit careful there, because it depends what you say with procedure failure. What happens often, first of all, we need to differentiate where this process takes place and what we define as failure. Meaning, when you start the process, you have actually two really rough differences. One is a planned intubation, the other one is unexpected intubation. So in an emergency setting, for example, when you have an accident on the street and you need to be resuscitated, or your airway is blocked. So the airway is such a weird term, but basically says that you have ability to breathe. So you have a connection between the lungs and the atmosphere. It's a little bit the scientific description for this. So you need to secure the airway. When you need to do this, and in a controlled environment, it's way easier. Meaning you need to do it, for example, before surgeries. And when you have mechanical ventilation, because if you have a complete anesthesia, then your muscles are always also relaxed, even your diaphragm, so you don't breathe anymore. But many people, when they have surgery, they don't know that because they are already like knocked out when they get intubated. This is actually the process. But there you have really low risk because those people, they do it on a daily basis and the failure rate is low and you have all the equipment there and everything is like clean because the patient needs to fast. The patient has already pre-screened and there's no time pressure because you have oxygen before you actually get intubated. So you still have oxygen in your blood and in the lungs. So until your levels desaturates when the damage happens and the tissue starts to die because it doesn't have oxygen, can take up to 7 minutes. When you have clinically ill patients, COVID or other like risk factors, for example, pregnancy or like heavy smokers, like then you have like a shorter time though. But there it's like, I would say there's really low risk for you as a patient. The high risk, and this is also the case where our innovation that gets more and more interesting, is when there are no experienced people. And here we talk, for example, in pre-hospital intubation, like paramedics out of the street, ICUs, emergency departments, or for example, the military. This is because the military and emergency medicine is kind of similar. Like let's talk a little bit rough there, but sure you have some differences there. And the other challenge is it can be bloody, it can be vomit, it can be foreign objects, there can be like heavy trauma and deformations, there can be tumors, and then like the intubation is not easy, and the desaturation is way quicker because you don't have like this pure oxygen, clean environment to secure the patient airway. And there is actually the failure rate quite high. But the failure rate often is defined with the first attempt success, so meaning he tries, he fails, he can try again. But when you think about it, the time in between is the issue. So there are statistics when you need 3 or more attempts that the risk for severe hypoxemia is already 28%. And then you have like heavy damages on mostly the brain actually.
Okay, that's super interesting. So if you try to put the tube inside, like, and it doesn't work the first time, you don't break too much, right? So it's not, so the issue is really just a matter of you lose time.
Yes. And often what you can do, like it depends on the situation, like if there's blood or whatever, you can also bag ventilate, meaning you also can ventilate via the mask, but you cannot do it when you have liquids, like in your oral cavity, because then you push the liquids in the lungs.
When does that happen? The liquid, the blood?
Like this happens when the patient's not like trauma, and then you have the blood, or for example, and the like a vomit can happen when the patient like has eaten before, of course. And a classic one is when you try to intubate, you don't hit the windpipe, you hit the esophagus, you pump air in there, and then actually everything comes up again.
So this could be the case mostly for the unexpected cases that you mentioned, right? If there's a car accident, the person has eaten before. It's not that they're fasted.
Yes, and also the point is in the clinic, even though like you have a planned intubation, and even if inexperienced people, when you have this, you plan that you have experience next to it. If the first attempt fails, you hand over, that they also learn. So in the hospital, little to no risk. But the more you go out, then like the issues start. The classic in the hospital is that people break teeth because they have like a metal plate you put in the mouth, but there's no severe patient harm, like to talk a little bit.
Yeah. Understood. And just a silly question, but like, so in what scenarios in the field do you need to do an intubation? Like at what point do you need that intervention?
Like there are 2 main ones. Like the classic one is the resuscitation. So meaning like when you need to perform CPR, like usually you just make the chest compression and then you make the old school one is like breathe in the mouth. But what if the airway is blocked? Then you can circulate the blood as long as you want, but it doesn't get better because there's no oxygen going to it.
And why would the air? Why would it be blocked?
Yeah, and this can often happen, like for example, if there is water in the lungs, like with drowning, or like liquids, vomit, foreign objects. There are several points you can have that there's something in there and you have no connections between the lungs and the atmosphere. So the easiest one is to say when the airway is blocked. And then you need to perform a tracheal intubation is airway management, it's called. So you need to manage the airway. And when you have secured the airway, then you can go to the next steps. But also thinking about it, also like in the concept of like the resuscitation doesn't make sense when the airway is blocked, puts like this process really to the life-saving / life-maintaining procedures, like to really go further with it. Like when you go, for example, first aid, you have like also like it depends which system you're trained, but the airway is also like one of the first you check because it's important like to move further down this decision tree.
So, and what about, I saw in the past that sometimes people, so
tracheotomy.
Yes. So
yeah,
that,
like,
I mean,
yeah, you can do it. It's always risky. Like looking in the military, that's often like also the case, but it has only, I think, like a 30% success rate or 30% failure rate. Like don't quote me on that.
Yeah.
It's either 30 up or down, but in both ways, it's awful thinking about it. So
okay,
ideally, you can use the other method easier, but for example, try to imagine your vocal folds, like they swell or for whatever reason, if allergic reaction, it closes. Yeah, then you need to cut. You cannot push like the tube through that. There are also other methods, like easier methods to place. For example, the laryngeal mask, which you just like make like a kind of a cup you put around the vocal. Afterwards, we see some videos, like around the trachea. But the issue there is sometimes it's hard really to make it like dicht. So it really like isolates so that no liquids come in. And like it's not always given the situation that the anatomy like really helps with it. And when you have liquids, you sometimes like give the liquid also like into the lungs anyways. So the gold standard is always an intubation, but it's tricky to place. This is a little bit the starting point of this whole venture.
I read somewhere that at least once in your lifetime, everyone will go through either an endoscopy process or a tracheal intubation at least once, right? Is that true?
Makes sense because the intubation is like really a typical standard process. It's performed over 50 million times a year. So 50 to 80 is like the guess. But the heavy, like the majority of this is like in a really safe hospital setting. And the other thing is you see like the growing field in endoscopy, because there the trend towards prevention and early detection is on the rise. And this is a super, with advanced camera technologies, it's one of the best methods to make this like minimally invasive or even like use natural offices of the body to make it like for the patient like painless and like as painless as possible.
What are the first signs that I see that tell me I need to go get an endoscopy right now?
You need to ask like your clinician like for this. Like classically it depends like about your whole patient's journey, but like for example you can also, many people like they go for a colonoscopy early, or you have the bronchoscopies you have when you, for example, a smoker, you have indicator that you have like some tumors there. It really depends. There is a broad spectrum. It's often when you have certain symptoms because it's a super general thing. And then the clinician like says, yeah, I want to have a closer look at ... And then he looks at the methods and then he picks like the endoscopy. The other cool advance though is like, for example, you can also use like endoscopes, like for example, with surgery now, that you don't actually cut open the whole body, and again, you go in the so-called laparoscopy way, that you only place actually tubes in the body, that you don't need to cut everything open. This is the other applications. That's not only diagnostics, like Da Vinci is the famous example, but you use actually a robotic system there.
So it's a huge field.
Yeah, it's way too big to answer this question like that easy.
Yeah, so it's a big field. It's a growing field, and it makes sense why it's growing as well. Yeah. Your focus area, however, is really the tracheal intubation in the emergency setting, as I understood it.
Yeah, you gotta start somewhere.
Okay, super.
Why did you start there?
Cool question. Historically, actually. So it started with the whole venture, starts with a clinician who had this idea, who went to ETH, who then like kicked off the whole process where my co-founder picked it up and started to build the first prototypes. And after a while, we realized actually what we built here is kind of a platform approach. So we could target other fields as well.
Yeah.
But we still decided to stick with it because of two reasons. First reason is it's technically easier than others. For example, if you now go to laparoscopy, for example, like this, the most extreme case, you don't have like fixed shapes around you. So the training is way more difficult. And also it can differ quite a bit where you actually make your surgery and what kind of surgery. And then like it blows up. And the larynx is plus minus the same. Of course, there can stuff happen, but it's like a kind of a solid structure. Also, it's a so-called tubular endoscopy, meaning you have not like a free space floating around you. You have always like kind of tubes around you. So it's easier. So like one was technologically easier, and the second one regulatory. In medtech, you need to know that and the difference between engineering startups and medtech startups is regulatory. And regulatory is the same thing.
That after
Yeah.
your pitch.
Yeah, like yes. Then I make a spoiler. Like medtech is regulatory. Medtech is engineering, just as more documentation. Yeah, innovation. Let's slow it down. Yeah, but it's also good because
And the tracheal intubation is obviously where there's a lot of mistakes that happen. So I would imagine there's a lot of room for improvement there as well.
true. Like the last innovation was done in like the 2000s, where they put a camera there to make it easier the visualization. Where the first and otherwise it's still like the main tool you have is the laryngoscope. It's a kind of a shoehorn. It's an L-shaped shoehorn, which you use to lift the jaw and make space that it can push the tube in hopefully the right pipe.
Okay, cool.
Should we hear the pitch? So we're going to listen to a 10-minute pitch on Philip and his startup. And then after, we're, of course, going to ask some questions
Sure.
about it. Here we have your slide. And whenever you're ready.
Perfect. So the pitch is quite easy. So at Endoscopic, we want to simplify endoscopy. And the idea is we do this by bringing a computer vision in to bring the expertise to the place where it's needed the most. And the first application is, as we already discussed before, is tracheal intubation. And Joni also has like a nice video there, which actually you can see the process. It's like we often say, a picture tells more than 1,000 words. So for the people only listening, I can also like talk you through. So basically what you do is you have in the left hand a so-called laryngoscope. It's like an L-shaped shoehorn. You put it in the oral cavity of the patient and place it at a certain spot. It's called the vallecula. There you use it to open up the epiglottis as a lid, which you use to actually to close the trachea, for example, when you swallow something, and push away the tongue. So you have space that you can use the right hand to place the tube like via the mouth into the windpipe of the patient. When it's there, you inflate a balloon. So it's actually like sealed, so no liquid can come in afterwards. But there's one big caveat to this, and this is that the human anatomy is designed and built in a way and evolved in a way that nothing solid should enter actually the trachea, because this should go in the food pipe, in the esophagus, and this makes this process quite tricky. So you require quite some experience and training to become proficient in the skill. When you look at numbers, for example, in the US, the paramedic only trains this process 5 times. Even 200 times is recommended, which leads actually that about half of his attempts fail. When you then compare it with an expert, only 15% of the attempts fail. So you need to try over and over again. But the issue is the more you try, the higher the risk for severe hypoxia. And there's a famous a study by Henry Wang, where he in the end quotes that you could save up to 10,000 lives in the US alone each year when you just like improve the intubation method. And especially in US, it's such a US case is like the litigation costs, which are massive because the patient harm is huge when something happens. So looking into the problem we set together and thought like, how can we solve this process? And we said you can target all of those 3 steps individually because you need to plan before, during, and afterwards. And we came up with an idea. And the idea is that we use AI to bring the experience to each of those steps individually. We call it LaryngGuide. So it's like a software which we implement in the existing platform to not make a disruptive change, but to enhance each individual hardware to support the clinician. And we made out from this idea, we made a kind of a suite, meaning we want to target the training with LaryngCoach, LaryngGuide for the clinic, and LaryngGrade for actually the data management afterwards. Why do we make such a big difference between LaryngCoach and LaryngGuide? Well, we discussed it a bit before, it's regulatory. LaryngCoach is in a simulation environment, so you don't need to like have all the regulatory hurdles. You're way quicker in iteration. You can deploy software quicker. You can push, pull. Data management is easier. There you can make like a lot of experience. But as soon as you go in the clinic and you're certified, every change is quite cumbersome. So you want to avoid changing it. So you want to make the trials in the training, go to the clinic, make like a solid platform where you have a proper performance. And LaryngGrade is the one like for the data management and actually supporting then the quality management. How does it look like? And then it's like the easiest one if you just look at the video. So meaning the shoehorn now, the laryngoscope has already a camera placed. And what we do is we use computer vision to detect the anatomy with classifier and object detection and some logic behind it to support the user to place this shoehorn the right way, similar to a car where you need to squeeze into a parking spot and you have like these lines that help you to place it the right way and also warns you, for example, for collision detection. Here you saw the back signal when you like to close actually to harm the larynx. The blue tick boxes here means like you have a good view. You can start with the tube. And here, this is actually the most important part. It's a classifier that actually helps you to see, is the tube actually in the trachea or not? Sure, you can now argue you can see it, it's obvious, but when you go to the clinical version, in a sec, you can see already like some advantages in this one because AI is really good even like with blurring. And it's always a good advantage to have like this seatbelt mechanism, like a second pair of eye, even though it's robotic, to confirm your choice. Now you might ask, is this good enough? Just like some guidelines. And the first study is like they say yes. Like we made a study with the Schulthess Clinic where we could show, like we made a comparison between the video laryngoscope and the AI enhanced video laryngoscope. And there we can see already like an improvement of 70% less failed first attempts, which is actually massive and comparable with the last revolutionary step where you just put a camera onto the laryngoscope. This also got the idea, do you learn quicker? And there we saw also like an improvement when you compare like those numbers, like it's a 74 intubations you need in a human to get a 90% first attempt success rate, but it's in human and we compare it with the mannequin, so it doesn't work 100%. And there we needed 9 to actually also reach the first attempt success rate over 90%. And this brings us actually already to the next step. And we said, this is cool. So push it in the clinic. This version works. So what we did is we used clinical equipment. We used the HDMI output of the video laryngoscope because the hardware currently cannot run such an AI model on it on top. Plugged it in a computer and then used this image on the bigger screen, which is then the image the clinician can use. And the big and cool thing about it is we CE certified this one with the class 1. So we made some limitations and like a clear statement what it really can do. And what it does is actually only provide additional information and to actually go for the first clinical trials, which are ongoing now in Inselspital in Bern. When you click on the video, you can also see actually how it's actually the same thing, just a different anatomy, like with like an old watermark, but this video is not confidential anymore. But the advantage here you see already is whenever you have, for example, in this case, it's when the patient exhales, it's a classic thing because there's still lung and like some water vapor in the lungs, the lens fogs up. But the AI still has like enough training to quote unquote look through the fog and help the user to guide the tube. So it helps the user to de-stress him and give like with the mental load to help in like for a successful process. And best thing about it, it's CE certified, which is always like a big question if you want to do this, especially as a startup, because nowadays the MDR in Europe is, to be politically correct, like slow, really slow. So you still have waiting times above a year, which can be like the death of a startup because you just burn through cash doing nothing. And we made a class 1, but it was also like important for us that we limit our features and what the code can do, that we achieved that. And for the FDA, the big advantage is you can go for a 510K because they're similar devices where the intended use stays the same. It just gives you additional support, additional informations. But if you keep the intended use, you can use the previous already certified device to go it to the market. Last but not least, the third branch, Laryngrate, is the other approach where you just use a server and you let people upload their videos and they get analytics back. This helps them like to not only structure the data or like help in their teaching, but also then for us, because for us it's like a great tool for data collection and improvement of the AI to enhance actually the software, like keep it like the classic medtech improvement circle going. But now let's have a quick look on the market. And the market is actually a sub-market of the airway management market, which is about, now it's already a little bit bigger. It's about 2 billion in size. It always depends which tools you really count into it. But looking at the video laryngoscope, it's about 500 million. Of course, now every investor would like walk away looking at this number. But the big advantage there is like you can really target because the field is not that big. You use like the classic big companies there. And the market though is like growing rapidly because it's the next innovative step and it will become the gold standard. I think like this is not a big up to debate anymore. And that's actually the idea that you start on this wave and you ride it with it to really push the device on the market. Looking on our business model, so we started actually in the beginning with a robotic solution, but then we said, no, we pivot to a lean software solution, is to go for a licensing model. So you go to a manufacturer, which sells the device anyways. Such systems cost between 10 to 15K, like the premium ones, which we actually target. And what we do is we give them the chance to enhance it with the software and then make a cost split where you give like the company, the manufacturer gains some money and you gain some royalties, and the recurring revenue you get via updates or subscription models. When the subscription model in the training market is more established, you see also trends now going into the clinical field where now it's mostly done with disposables, but now software also takes already the first steps to establish themselves in the clinical field. To license something, you need to have something, and what we did is actually patented it. Now the first people will say, yeah, you cannot patent codes, you can only copyright code, and that's most of the time a stupid move. What we did is we patented the hardware. So we made it a little bit indirect. Even though we license the software, we patent the hardware, meaning every instructive laryngoscope is protected by our patent. So even though they could copy the codes, they couldn't commercialize it because in the end, it's still, they need the hardware actually that the code makes sense. And that's actually our approach to it. Yeah, but honestly, like now it makes sense. But like we started with the hardware, and then we realized, hey, actually we can go this path, and it gives it like a lot of like calmness because then especially medtech and the code you can copy way too quickly. And looking at the roadmap. So we incorporated 21 and the project started in 2018. but really working on the codes where in the beginning we went with the robotic solution is 23. So what we did in 23 is we tried to blast out all the milestones. So we did the mannequin trials, computer testing. We started the first in-man trials. It's still ongoing, the first in-man trials with Burn, but it's like the patient recruitment is already done. And we are already like in discussion with like signing the first partnership agreement. In 2016, we wanted to sell the first trainer system, which we already did in 1 year before. And the goal was then like to also expand the software certification to the FDA to really like start to widen our reach, because the American market is actually the target market, and we should like move us away from Europe ASAP and like work with American companies. The quicker the better. Not move away from Europe, but focus more on America. That's I think is like the better statement. And the big advantage is also like, where are we now? So the software pivot helped us a lot to open up many doors. So we have already clinical studies going. We also have already a poll at area management conferences. It's like the niche of the video laryngoscope. And we already started the first paid pilot and launched some projects. But the most promising indicator is that we have LOIs for collaborations, and one is actually one of the leading companies, which is Karl Storz. It's a German family-owned business, to implement this technology. And the other thing is we saw already some other companies presenting our technology, or like in collaboration at conferences, and where they tested how people like respond to it, and the feedback is really positive. That's one. In the end, the team. So when you look at the first glance on it, it looks like a classic tech team. And it is kind of, and it's like all of them have come from ETH. And now you might say like, this is not diverse, but if you get to know us, like we are really different, like in a way of thinking. And also considering that we are in this venture for quite a while, we also differ in the way of like acting. So meaning myself, if you don't ask me to code anymore, like it's dangerous to let me on the source code again. But for example, Dave knows every letter and point and comma in the code. So he's like really the CTO, and he is American from Wisconsin. And he also like worked already with some other engineering companies and worked on this project like from 2018. The other David, it's also like an American, but he's from New York. And so we said name one Dave and the other one David. And he actually also studied robotics. Had also a semester thesis on the project, then went into innovation management, and in the end ended up like back in the company where he takes over more the commercial side. We have like on the board, of course, the investor sitting there, but looking at the team, we have Hirat. He's amazing for embedding. He already started like our first prototypes were AI embedded in an FPGA, which is he pulled off on his own, which is actually ridiculous. Some people I couldn't believe, but we had the prototype to prove it. And Federico, he is actually also like the first like employee where he started actually picking up the codes and enhanced the model like crazy. And most importantly now also this the network to the KOLs, like the medical field, because you need to understand them. And now the big point is when you look at the whole business plan, is that the story doesn't end there, because our goal is, and what we built together is an infrastructure which you can scale really easily to other endoscopies. And that's actually the strength and the value of the company. You remember the market, which we talked before with the $500 million, but when you go in the global endoscopy market, there's no ceiling. So the goal is to start easy, technologically easy, and then expand from one application to the next, where you already have a proven track record and you can scale quicker and quicker with each application, but you turn the difficulty setting with each one a little bit higher. And with that, I hope I gave you like a quick introduction, what we do, where it stands, and I'm looking forward to the dialogue.
Thank you, Philip. Johnny, do you mind if I shoot first? We cannot hear you, by the way. Yeah, we cannot hear you, but I'll start. So
I said you can start. Sorry, I muted myself.
Yeah. So you said that like in order to kind of, build some moat around your business, which is software, not hardware, you work with patents. Now, can you secure these patents across jurisdictions? I guess that's the first part of the question. Then the second part, when you scale then to other applications, can you use the same playbook for that?
No, yes, we're in national phase with most of the patents, and some already are renewal, like with all of them, but it's a good track record, so we are not scared that they fail with the application. And we actually protected them only in the main markets. So we use China, Europe, US, which is classic. It's a little bit the startup approach to grab the biggest chunk of the market without spending too much money. Now, of course, you can always debate some countries if it makes sense to patent, but if you do it, go for it. The approach works really well for Airway and everything around, which we did already. For the other ones, we need to be careful what we develop there, 100%. This is a really good point, because especially some fields are really hot currently, and some fields are more niches, where you can also establish yourself similar to Airway. A really hot one is bronchoscopy, where now Intuitive makes some big moves, but also other big players are already involved, like for example, Medtronic. And there, the patent landscape is already really dense, and they went crazy with robotics even, where both of their platform have like navigational support and robotics there. So there's an approach there, and there are some strategies. For example, what you can do is you can make a counter movement, go not in the high price sector, but more in the value sector there, where there's a strategy around that where I don't want to disclose too much.
Sure. Yeah.
Which you can cut out.
I just wanted to follow up, because we're on the topic of patents. Philip, you're the only startup I know that is the spin-off of 3 universities. I've seen a lot of 2 universities, but you're a spin-off of University of Zurich, ETH, and the University Hospital of Zurich. How do you manage that?
Yeah, that is actually, it's also like the history, but on the other end, you can see it's super interdisciplinary, because it started off with an idea of the University Hospital of Zurich, which come to ETH, who also did work on it, but the first funding they got from the University of Zurich. But it's also another point is when you do research at the University Hospital of Zurich, this is actually led by the University of Zurich. So the clinical thing is USZ, but all research is UZH. And this also made the patent negotiation tricky. So our first patent negotiation, I think every startup, especially in early stages, complains about the patent negotiation. And in our case, in the beginning, we didn't take the patents because we said, look, it doesn't make sense. The conditions are too bad. And often what you have when you have a university writing the patent is that the quality of the patent is quite bad, because they produce patents on a daily frequent basis, never knowing if they actually get used at some point. So when the entrepreneur is not really standing behind it and also is involved in the process, you have a high risk that the patent doesn't really has a big value. So you take it and then you need to patch it right away afterwards. So sometimes it's also, you see the approach that spin-offs, they don't take the patent, advance the technology, and then patent this one.
Can I ask you another more commercially oriented question? So am I right? So by the way, the reason why I ask is I've seen, I'm sure we've seen a lot of startups who have ideas and concepts who really do make the world a better place, and that's what we like to work on, right? And save lives ultimately. And some of them actually don't manage to get the commercial traction that they initially envisioned. So that's kind of a typical problem. And now in your case, I guess, can we say that this video AI assisted tracheal intubation is not going to be possible in the US without working with your patent?
It's not going to be possible without working with the patent.
Yes, without partnering with you. So in other words, can competitors step in this space, or have you secured yourself to a degree that
honest answer is always like you can never be sure that a patent holds 100%. And even if it holds 100%, like there are also, you can just infringe it, then like start legal battles. So a patent is not always a guarantee that you're really the sole leader there.
More
There are
like
even
a
like
defense
courses
strategy.
yes, like it's sure, like there you can say a big player can do whatever they want and you cannot afford the legal fees, but then you can, for example, use it with this competitor. And like there are really many ways with the patent. I think in general it gives you good cards in the hands, but then it's also up to you how to play it and how the other ones play it.
Nice.
I think it's always I think you need to look at it pragmatic and not idealistic, where in the end the world is like chaotic and
Yeah.
depends who asks. Yeah. But the honest answer is like it gives you good cards, really good cards.
I wanted to
That's
add
our
here
guarantee.
also for the listeners that when you were pitching, probably they didn't understand. So you mentioned you have Class 1 CE mark and 510K exempt from the FDA. What are these in very layman terms?
Yeah,
Like,
okay. Perfect. Like refresher, because like sometimes this
what does it
regulatory is
mean?
like it goes crazy.
What does it mean in case you
Yeah.
don't have this? Can you sell? Where can you operate?
Okay.
I think just a quick overview. If you
Like
can.
the quickest overview is like, first of
Very
all,
quick,
you need,
yeah.
whenever you have a medical device, you need to certify it as a medical device. And why does it make sense? Because otherwise you don't get reimbursed. So like all those health insurances and hospitals cannot use it as a medical device to get like the money back from it afterwards for the certain.
Yeah, but
treatment.
also if there's a certain user or a patient that buys it directly, like you basically cannot sell your product if you don't get.
You can sell it, but
regulatory
not
approval.
for medical usage.
Okay.
So you can say it's medical grade, but it's you cannot say that it's the clinician gets actually the money back using it. And then there are regulations when it's already a medical product.
So you said you've got some LOIs. You're in close contact with product manufacturers. Do these product manufacturers have any visibility in terms of like offtake agreements in terms of being able to sell the product? Because I guess you're going to generate revenue only if they manage to sell the product in the market, right?
Yes, but those now I cannot disclose, unfortunately. Like
Okay.
they're really like they're tied. Like it's family owned. Like the one we were really tied,
Yeah.
and the other ones they're also in a public traded.
But do
And
they?
the pu-
But do they? So the question is more like, do you have some feedback from the market together with the manufacturer that there's going to be demand actually to. Okay.
Yeah.
Okay.
And how they want to implement it, I also cannot disclose because they have different strategies.
Okay, but
Like
just to break down
classic
your business,
medtech, yeah.
to break down your business model. So you just now, right after you pivoted, you just produce software and you're selling this to manufacturers.
Yes.
And
Exactly.
manufacturers have very high confidence that they're going to be able to place it in the market
Exactly.
because
It's
of
like
because of litigation costs, because of it.
The big advantage is now, okay, this I can say. When you ask a question, I can say like, why do you want to implement it? I think that's the best answer. So when you ask why they want to implement it, it's because currently looking at the field, there's no innovation on the market and the market is quite saturated. Looking in the medtech, the sales cycle take long and to really make a competitive account conversion is tricky. So you need to come up with something new. And what the people did is now they improved the camera, they improved a little bit the handle, but that's not a strategy they want to go for. Like other big player in the US, they want to go for sustainable plastics. But when you talk with clinicians, they say, yeah, I'm interested in clinical outcome and improvement, but not for like economical improvement. So if your AI actually does it, I would switch to the AI company and not to the one that gives me like the biodegradable plastics. And this is actually the thing. So our enhancements allow people to come with a new USP and really like enhance their endoscopes in comparison to their competition. And the idea with the patent is like that we establish ourselves on a way that they need to pass via us, that we can really like establish a new technology with the goal to become the gold standard at some point.
Okay, super. And
Maybe,
yeah.
Okay, Roman, please. No, you go.
No, in interest of time, we do have, from time to time audience members who actually take real interest in any given topic. Last time we had depression, actually, we had some interesting follow-ups from that topic. So do watch it if you haven't watched it already. So what would you say in terms of, someone who's really interested and wants to get involved? How can they get involved and how can they support?
And of course, reach out. It depends where you want involved. Are you a clinician and want to set up pilots? We're really ready for that. And also, we're always looking for people and the right branches to come out. Of course, we don't have a special needs currently, so we're not fundraising at the moment. But it's always interesting to know if you are in the medtech field, if you have a clinical contact, or if you want to get involved or work at a company like ours. Those are open, and the contact details are sure going to be shared with you somehow.
Absolutely. And no, moreover, so I wanted to say that we at the Catalyst Conversation, we also have a Discord channel that will invite you, Felipe, and create a forum point for AI endoscopic. So you're going to be there, and whatever listener is interested in any topic that wants to chat with you, they can reach you there and discuss in the forum.
Perfect. Sounds great.
Okay, cool. Thank you, Philip. And we wish you a lot of success. And
a lot of customers.
Yeah.
Thank you.
We'll be following your story very closely, for sure. Thank you very much.
Thanks for the interest. Thanks, guys.
Perfect. Thanks.